start with the second talk scheduled today. AI deployment, no regression, no regrets. So I would like to call upon Shoaib, Ahmed, and Harikrishnan. They are senior software engineer at Abnormal Security. So please welcome them on stage.
We have people flowing, we can start it. All right. Good morning, everyone. I hope I'm audible. Do I need to be louder? All right. So as Shabnam mentioned, we're from Abnormal Security, and the title of our talk is AI Deployments, No Regressions, No Regrets. And it's quite ironic that we say, go ahead, be human. It is normal for humans to err. Then why do we say that we are able to deploy confidently without regressions and regrets? That's what we're here for, to tell you how we do it, and happy to hear from you what you think is a better way or an advice that we can get as well. To do that, we have two of us. I'm here just to do a quick intro. Hari can talk about himself.
Hello. Can you hear me? Mic testing, 1, 2, 3. Always wanted to do that. Hi everyone, good morning. First of all, I'm happy and glad to be here at talking to everyone. I myself, Hari, senior software engineer with over a decade experience, mostly working in a startups where I helped turn ideas into products, and also from going from 0 to 1, or working in a scale where I have to take the challenges that arise only during 10 to 100 phase. I have worked in a startup that focuses on edtech, logistics, ad tech, so you can say I've seen a bit of everything. Right now I'm leading a new team called Testing Automation Platform team at Abnormal Security, tackling the challenges that comes with phase 100 to 10 to 100. So I'll be talking more about it in the later part. But outside of work, I enjoy writing technical blogs, traveling, and then cooking. Yeah. Apart from that, I'm father of a 4-year-old boy and 2 dog pets who keep my life pretty busy.
And I am Shoaib. I believe myself to be a geek. I like to code, as most of you here. During the day, I code for work. During the night, most part of it, I code for fun. My interests have been quite varied. I was initially interested in IoT, so I joined GE. I worked in the industrial IoTs, building out large solutions for their manufacturing. And then, well, right now that passion is basically making cat feeders, automated cat feeders at home for myself and my cats. Not myself, my cats. And then I was really keen on productivity. So I spent the next 2 years after that building a platform for individuals to get better with their time. And this was a time during COVID where everybody was struggling with it. Well, that didn't take off, but I soon found Abnormal. In Abnormal, I've been here for a little more than a year. I've been building out the pipeline, ingesting behavioral data. We're pulling in billions of events each week, each day actually, and that is what I do here at Abnormal. And to just give you a very quick intro to Abnormal, and I'm doing this not to tell you a history, not to give you a history lesson, but to just give you a background as to what Abnormal does. So the talk after this is going to make a lot more sense as to why it's so important for us to deploy with confidence, without any regrets. So Abnormal started back in 2018. A group of individuals got together and said, we want to stop phishing emails. And how do we do that? They collectively decided, we're going to use something which has got us to PyCon today, and that was Python. They believe Python is how we could go about building this product, this company, and then Abnormal came to be. Since then, Abnormal has served more than 2,400 enterprise customers, and Python has been vital to its success. And what part of Python was, one, being very friendly to the AI community, and second, being very flexible to iterate really fast. And that is one of our core values. Velocity is one of our core values. And today we are processing over 1 billion activities. Yes, that's a billion with a B, activities per day. That includes your emails, behavioral data, that's audit logs, and we're protecting more than 20% of the Fortune 500 companies. And just remember, we started like 2018, 7 years back. And Python has been the centerpiece of all of this that's happening and powering the AI of Abnormal. So just to give you a quick brief of what an AI tool looks like at Abnormal. So this is a product we rolled out just a few months back, AI Security Mailbox. In very short, it is a conversational AI using the latest Gen AI tools out there to provide automated security analysts to our customers. So to not bore you with specifics on the product, what does it look like? Raise of hands, how many of you have actually reported a phishing email in your companies? How many of you actually got a prompt response from the security team? That's less than 2% probably, which is the reality. It's not possible for every email reported to be responded promptly from the team because, again, it's only a human. So what we built out was with our engine, the phishing engine that we have at Abnormal, which is world-class, by the way, we interfaced it with Gen AI that any employee can just forward an email like Jonathan did. He's not familiar with Jenny. He just sent out an email to Sally, which is a bot, telling that, hey, I don't know who this is. Should I respond to them? And Sally has all of the data of the organization, understands who this person is, which is Jenny, and responds that, yes, this is a safe person. Other team members of your company have been interacting with her, and it's safe to continue the conversation. Now, why do I take this example up? This is a real-time reactive system, right? This is going to be responses from a person's activity, which requires zero downtime because if we are not up, somebody is not going to get a response, and they likely are going to interact with a malicious actor, which is bad. But that's not it. We have a massive behavioral AI platform. And, well, I would like to term this as a proactive monitoring system as opposed to the reactive system there. I'm sure a lot of you dislike behavioral data being used because it's widely used for targeting ads and pushing content to your screens. Well, Abnormal thought of it in a different way. We use the same techniques, similar data, but we use it to target, identify malicious actors and eliminate them from your systems. So your mailboxes, your networks. So how did we go about doing this? We essentially ingest terabytes of data. We are tracking every single action performed by every single user on every single cloud platform within an organization and find the sneakiest of actor hiding in there trying to do something malicious. And we eliminate them immediately. It goes without saying, if we are down, essentially our customers are exposed to attacks from outside. But that's really not the problem or challenge for this kind of scale, right? It is to be able to build this platform, we needed tremendous amounts of data. And mind you, all of this data contains a lot of PII because we are tracking every single motion of an employee in a company. And we aren't allowed to give this PII data to our engineers to develop with. And that's where Hari's team comes in, the TAP team, right? How do they allow us to iteratively build, train, iteratively develop on top of it, and finally deploy with confidence that whatever we've built is going to work for our customers out there. And with that, I will stop. I will pass it on to the more interesting part of the conversation. Hari will talk through how we are doing deployments at Abnormal. Thank you.
Yeah, I think before I get adjusted to the new slide, since we are both cat and dog lover, I just want to see like how many are dog lovers, how many are cat lovers. Just a quick survey. Dog lovers, okay. Cat lovers, okay. Dog wins thing. Okay, thank you, Shoaib, for laying the foundation. Like any hyper-growth startup in the like 10 to 100 growth phase, Abnormal faces its share of challenges. We are no exception. I'll deep dive into the specific part today, like that will focus on working towards how we are achieved the high confident deploys. Like Shoaib mentioned, we deal with billions of data points every day. So some of the code services, which is scoring, underlying scoring services, which runs at 4,000 plus instances. And it can reach us sometime up to 5,000 instances during the peak hours. So that tells us the volume of data that we are dealing with. So we are also committed to delivering 99.999% uptime to safeguard a customer from any potential threats. Yes, you heard that right, like 5 nines. Yeah. So why it is matter? Because any bad deploy that can go in, right, sneak into the production, that inadvertently creates a threat to the our customers, right? So any invoice fraud can happen, any phishing can happen, a lot of things can go, anything that can go wrong can go wrong. Yeah. So this puts us in a position to have no regrets deployment, to uphold our uptime and security commitments. Okay, these are the challenges. So what we are doing to address those challenges. So like most do at a company, like we sat down and figure out there are a couple of gaps in the deploy release workflow, and we came up with a couple of ideas or ways to address it. So automated canary analysis is one of them, which I'll be mainly talking about here. Then we spent some time around the quick research. Then we shortlisted a couple of frameworks that supports automated canary analysis. Did a couple of quick POCs to figure out which works for us. Yeah. Now that actually worked on production, but then we understood, okay, this is really not helping with testing on test environment, because that's what we want to do. Like we wanted to test it on test, then we want to do it production. Then we understood that the ACA is not really helping because the test environment does not have any test data flowing in that can help you to validate effectively and automatically. So that's when we built a test data simulator to actually simulate the test data without any PI. Yeah, then what we did is we enable daily automated deploy for one of the scoring service using the above tools that I will talk about in the later part. Yeah. Before me jumping into like what ACA it is, how it is helping us, like let's assume about the typical release workflow of what we do at company, like at least my previous experience, right? You create some PR changes. Like I'm going to pull Shoaib here. He creates some PR changes, and he creates a PR. Then CA runs unit test runs on CA. Then it gets passed. Like you have some level of confidence, right? Okay, unit test is passing. Then you go and deploy it and test, and you run some more tests like integration test or like browser test. Then you'll have a little more confidence. Okay, things are good, all good, going good. Then you go ahead and deploy in production, thinking all are good, right? Then what happens? Like after a few minutes, you get paged. There's the shit going wrong. Like but 5x is happening, the CPU's utilization is high. Then you sit on the laptop, you try to understand what's going wrong, and you revert. First thing you do is like you revert back the deployment, you find the root cause, you redeploy or like change for later and wrap up the laptop and go to sleep. So we have been there, done that, right? Like at least some part at some time. Yeah. So we want, though like unit test, integration test gives some level of confidence, we wanted to increase, we wanted to cover what that can go wrong during deployment or after deployment. So that's where the AC comes to the rescue. What is canary analysis? So it's a software development practice where you deploy a new change to a small subset of user before you rolling out to the entire audience. So what is the automated canary analysis? You do the same thing, but you have a frameworks and library to do that. Okay, we already, at Abnormal, we already have a canary setup for both all the services we have. What usually the workflow before ACA works is that we deploy service to canary, and we'll have a couple of dashboards with like fancy dashboards in Grafana. You go and monitor like what's happening, error rate, latency, traffic and logs and CloudWatch, things like that. And somebody have to do like on-call engineer or somebody will have to go and monitor the change, and they will make a manual judgment that, okay, things are going, okay, it looks fine, let's go ahead with the deployment, right? Then the deployment goes and like it all adds a lot of delays, right? Like, and there is a chance of human error in the whole process. So that's where AC comes into picture, where all the human intervention is removed. So talking about a couple of benefits, it actually helps to detect the issues at the earliest stage by comparing Canary, which is a new release, and with the baseline, which is the old release. And it helps you to compare the metrics between both. Then it will make you a proper mission, or what do you call that, like properly made decision. Yeah, and it should provide data-driven decision whether to proceed further or not, like whether the new changes looks good or you want to roll back, some things that you should provide. That's what we look for, right? That's the benefits of ACA. Okay, skip one slide. Yeah, sorry, I skipped one. Yeah, we like I mentioned in the previous slide, we wanted to these are some of the tools that we want, which ACA is supported. So we came up with a couple of rubrics where we wanted to make calculated decision. So we want to know that like canary analysis supported or not, whether it can work in standalone mode or not, whether there is provides A/B rollout, things like that. And we are on AWS, so we wanted to check and we use ALB a lot. So we want to make sure that it's supported or not, and how big it is, how difficult it is to bring that ecosystem into our use case. And we also wanted to make sure that it's stable and good. We don't want to, while trying to tackle the stability problem, we don't want to bring more stability problem, right? So that's what we wanted to have, this kind of rubric. Then while checking all these things, we, though whatever we wanted, like which is underlying automated canary analysis, all the three tools provided it, but we went ahead with Kinta because it works as standalone, and we don't have to make a lot of changes in the existing ecosystem, which will delay the rollout or like it creates more problems. We don't want to do that. We don't want add more stability issue, or we don't want to add more trouble to the application team. So we went ahead with Kinta, and not just because of that. It mentioned like it provides advanced metric-based decision making. So, and we did a quick POC to see like which one is giving a better results. And for us, at least, it Kinta worked out. Yeah. I'll keep it a little short on this. Like it's a tool, Kinta is a tool which open source tool developed by Netflix for automated canary analysis. Like I mentioned, it helps you to assess the reliability of the deployment. Its integrations works with Spinnaker, which we don't use. It can be used standalone if we conjugate with that. And it provides a detailed report. Like it gives a judgment where things are going wrong and what's happening. That level of detail, like okay, this is a score which is low, which is contributing to your deployment to fail. So it gives you that level. Okay, it's a chart that workflow provided by Kinta itself. So how it will look like? What's the baseline here? Baseline is your existing change that you will be using for comparison. Canary is a new change. Let's say you have rolling out a new change. That canary is what it dictates, like version 2.0, and production is where actual main workload is going on. Let's say you are running 100 pods or like 100 instances, right? So what you need to configure, you need to make sure like you want to route 90% traffic, 95% traffic to production traffic, 1% traffic to the baseline, 1% to canary. So you have to give it in a way that 98 pods will be assigned to production, 1 pod will be assigned to baseline, 1 pod will be assigned to canary. It's important to keep the configuration for baseline and canary as same as possible to have a proper judgment. Yeah. So this is the workflow that we have it internally. Before me talking about the workflow, like what we have is, Kinda is already there out in the market. It's open source tool. So what we did apart from that is like we taken that tool, we taken that source code, we did a couple of modification, then we internally hosted it. And also we built a CLI tool around it to create an abstraction to remove all the Kinda specific details. Like it, if somebody wants to go and implement, right, integrates a new ACA for the application team, those application teams need not to bother about Kinda configuration. We have abstracted many complex details, which I'll come to that in the end. So this is how it works. Like in the CD pipeline, you go and build a new changes, and you deploy the new changes in the canary pods. Then you redeploy changes on the baseline, which I already have. Once it is success, you go to the CLI, where already CLI is aware of what service that you're deploying, where you are deploying, and how long you wanted to run the deploy, ACA duration, things, all this will be there. You have this config, and that CLI tool takes that config and creates a new configuration on the Kinda service. Once that ACA duration is over, you will be having both canary and baseline running in parallel, right? So we have a Chronosphere proxy, which is our internal observability tool that goes and you have the prompt queue set up on the config. Then what it gets back is that Kinda does a lot of judgment. Okay, this is the metrics that it does the invert curve, things like that. It compares the metrics between the baseline and canary, and it creates a score for each category. Then it comes with the final score, whether it is pass or not, it's failed. That configuration, I'll come to that later. But if all good, if the judgment comes out to be good, like we go ahead with automated promotion. Yeah. So in the first slide, I was talking about daily automated deploys, right? Like there's a process improvement. So this is what the improvement we have done. Like it's the same ACA flow, but in the parallel, we have a ingester workflow running. What it does is that it takes the application team can create their own set of test data. Like for example, the scoring, the base test data is actually a couple of emails, right? Without any PI data. So we want to take application team creates a bunch of emails, and then they have it in, let's say, S3, and then you have, like, let's say 20 minutes you are running for ACA, you run the ingestion for 20 minutes. That what actually is happening is like you simulate the test data traffic on your test environment, right? That goes and creates a notification on the service. Then it goes and in turn creates a metrics on the chronosphere. So what happens at the end when the ACA duration is over? Test data ingester will be done with the ingesting, simulating the traffic on the test environment, because like there won't be any like actual traffic flowing into the test environment, right? So we wanted to make sure that we do enable the daily automated deploys. We want this test data ingest to be there in the testing environment. Then once the ingester is done, we have this ACA that gets triggered. Then it compares the metrics configured on the ACA. Then it makes a judgment whether to proceed further or roll out. Okay, this is how the config look, but before that, let me start a quick story about, like, I'm going to pull Shoaib again. He's making some changes around modifying some scoring rules that classify whether the incoming emails are like, whether it's suspicious or not. It looks like a regular update, right? But due to some manual mistake, what happened is that the incoming, the rule engine started allowing suspicious mail as flagged as a suspicious mail as a normal one. Okay, then it did not stop there. So what happened because of the incorrect rule, the evaluation started going bad. That in turn created a CPU spike. So if you wanted to achieve, right, this both things can, bring the whole system down. Like wrong mistake, one small mistake can lead to the significant impact. So I'll talk about like how these two things can be handled. One is like we want to make sure that we are not trespassing like the suspicious email. We want to also make sure that nothing gets into production, wrong code gets into production, which causes a CPU spike or memory spike. So if you're looking at here, like we have this different categories, which I was talking about, scoring and then saturation metrics. So we have the query for each, and there are a couple of placeholders which is there. Like here we have this, it's not okay. Okay. We have this environment, region, service name, bucket, all this we want. And we have this cluster, all these things. Like what it goes into this judgment, right? Like Kayanta, it all get replaced by the respective template, scope, which is baseline or canary. And it uses the, let's say the duration, which is mentioned here is like 30 minutes. We want to run the ACA for 30 minutes. And once that 30 minutes is over, Kayanta goes and gets the metrics from Chronosphere, and for both baseline group and then canary group. And it compares, and then it checks whether that particular group is critical or not. If it is critical, the scoring calculation will differ. If it is critical and then you configure threshold to have, okay, I am fine with like 5% decrease and 5% increase. And if it goes down like maybe 6%, the scoring will change. If the difference is more than like 20%, the scoring will go bad. So things like that. So then we have this below configuration where you say group wide, okay, now I want saturation group to have like 40%. Now I want the scoring to have 60%. That also finally affects your final judgment. Then we have a warm-up duration, which is pretty straightforward, where your application takes some time to boot up. So ACA will wait for that time to boot up. And we have threshold we mentioned, which is pass is 99, which is pretty good. We want the service to have like very accurate judgment. We want to make sure like if 90 is good, 99 is near perfection, right? So if the final judgment comes down below the 75%, we abort the deploy, or we'll not proceed further with the deployment. Yeah, this slide is about like how the final Kayanta understands. This is what we have it, or which application team have to interact. So it tells like a lot of things that we have abstracted with application team not to bother about it. So yeah, continuation to the word. Yeah, this is something Google provides, which there are four golden SRS signal, which talks about like latency, traffic, error rate, saturation. The good ACA configuration should have this. Apart from that, you can also have your custom application metrics. Having this metrics will help you to detect issues at early stage. Okay, have we rolled out like if we go and say to the application type, boss, I have created a ACA framework for you, like they'll say, go, I have some other things to do, right? So we have came up with the different modes and different ways where we want to roll out. So we say like, okay, you continue with whatever you're doing, but let's have it ACA within your workflow. Then we have this different modes where shadow mode, partial hands-free mode, and complete hands-free mode. What that first mode, shadow mode, does is that application team can completely ignore what AC is doing. The metrics will be the judgment will be pushed to Slack notification, or it won't even bother about the deploy flow. Like whatever happens in the flow, like it just sits there and just process whether it's good or not. It don't take any action on top of it. What's a partial hands-free does is that like once AC is deployed, the difference here is that human intervention is still needed. They have to go and approve or like roll back. These are the interventions there. Complete hands-free mode is like human intervention is no longer needed. Like AC, they have gained the confidence. Like maybe like it will take a couple of weeks deployment to understand, okay, AC is good because what you configure at the first time, the ACA is not going to be there forever. Like you have to keep iterating it to make sure that we are improving the metrics. We're adding more metrics, and we see more bugs. We have to do a little bit tweaking here and there. So that's why we have this different phase where you start off with a shadow mode, and then you gain confidence, then you move on to partial hands-free mode. Then you gain more confidence, then you reach a point where you can go and say like, okay, boss, I have very confident ACA. I'll go and make enable on the complete hands-free mode. Yeah, to end off with a note, like based on our experience and the strategic investment that we have on the ACA, we can confidently say that it really helped us to detect issue at early stage, to have a no regret deploys. I think I'll close the note with that. Thank you.
We could be able to take one question. If anybody has any question, I think you'll be able to come down to the left here, to my left.
Yes.
Hi, I'm Shardul from Springboard. So I understand the spirit of this is to prevent things from going down on production by catching them just before. My question is, how often do you actually end up rejecting PRs? And why I ask this is, would you think that this should be a much earlier part of the testing process so that your production releases aren't cancelled at the last minute shifting deadlines? So I would assume this is a great fail-safe to prevent things from going down. But do you often end up having to push forward release timelines because of this being a very late stage check?
Yeah, that's a very good question. Like, thanks for asking it. So different teams follow different release cycles. Some team follow like twice a week, right? Like some team follows every day deploy. So couple of things like you mentioned, like I mentioned, right? Like CI, on the CI you run unit test. Once you deploy and test, you run some integration test. That gives you some confidence. Where AC coming into picture is like what this test cannot catch it. Like for example, your code works perfectly on your local, perfectly works on test, perfectly works on somebody's neighbor's laptop, but it won't work on the production for some time, right? Like that's what it helps you to catch it. To answer your question, yes, it makes sense to catch it at the early stage. Whether we are allowing a lot of things to go past the stage, it's after this ACI, we have noticed that things are not going that far. Yeah, thank you.
All right. I think we are on time. But if anybody else has any questions, would like to talk, our stall is right next to Audi 1. We also have AI coding challenge, which essentially is the spirit by which we work at Abnormal. Do drop in, and happy to have a chat with all of you. Thank you.